Good morning to all of my students. Myself, Mr. Dibyendu Mondal, Assistant Professor of Mechanical Engineering Department of Greater Kolkata College of Engineering and Management under JIS Group. In this pandemic situation, I am delivering my lecture through online mode and my video is uploaded in YouTube.
Good morning, students. This is the class of Workshop Technology. Today, I am discussing about smithy and forging tools and equipments. Actually, a smithy work involves heating of a metal stock to a desired temperature, enable it to obtain sufficient plasticity, followed by the operation like hammering, bending and pressing etc. to give it the desired shape. This is known as forging. The above operation can either be carried out by hand hammering, by power hammers or by forging machines. Hand forging is the term used for the process when it is done by hand tools. Similarly, forging done with the help of power hammer is known as power forging when carried out by means of drop hammers as drop forging, and when by forging machines as machine forging. Applying the pressure for shaping the metal, the primary requirement always is to heat the metal to a definite temperature to bring into the plastic state. This may be done either in an open hearth known as Smith forge or in closed furnace. Small jobs are normally heated in the Smith forge and large jobs in closed furnaces. The hand forging process is employed for relatively small components. Machine forging for medium sized and large articles required very heavy blows, and drop forging for mass production of identical parts. Actually, the principal tools and other requirement used in hand forging. Actually, Smith's forge or hearth, it has a robust cast iron steel structure consisting of four legs support, an iron bottom known as hearth, a hood at the top and tidal opening into the hearth either from the rear or from the bottom. The hearth carries the coal and provided with fire bricks lining to withstand the extensive heat produced due to the combustion of coal. In the absence of this lining, the heat produced as stated above will directly affect the metal structure of the hearth, so that the body, particularly the bottom and the surrounding walls, may even melt. With the result, the entire structure will collapse and the hearth will no more be useful. Air under pressure is supplied by the blower suitably placed somewhere near the forge through the tire opening in the hearth. This blower can either be hand operated, power driven. The latter is preferable, but in the absence of availability of power supply, choice of the former has no alternative. If hand blower are to be used, they are usually mounted at the rear of the forge itself. In case the power driven unit are to be employed, The blower is suitably placed in one corner of the shop, and while the forges are connected with it by means of a well laid pipe running underground all around the hearths. At suitable point, auxiliary pipes are used to connect the tire with the main pipeline. A valve is incorporated in the auxiliary pipe just before the place where it is connected with the toilet to control the supply of air to the furnace. The chimney provided at the top enables as easy escape of smoke and gases produced due to burning of coal. A water tank is provided in front of the forge which carries water for the purpose of quenching. This hearth can also be made to have masonry construction provided with all attachments like chimney, tower, blower, water tank, etc. Anvil. To carry out forging operation successfully, proper supporting device is needed which should be capable of withstanding heavy blows rendered to the job. Workshop practice and anvil stand as the most appropriate choice for this purpose. Its body is generally made of cast steel, wrought iron, or mild steel, provided with hardened top about 20 to 25 mm thick. This hardened plate is welded to the body on the top. The horn or brake is used in bending the metal or forming curved shape. The flat step provided between the top and the horn is used to support the jobs during cutting and is known as chipping block. The flat projecting piece at the back of the anvil is known as tail. It carries square hole to accommodate the square shank of the bottom part of various hand tool like sages, fuller. It is called hardy hole. The circular hole provided near the hardy hole is known as Pritchell hole. The commonly used size of an anvil weight approximately 50 to 150 kg. Although it is manufactured in various sizes, the top face of the anvil should stand at about 0.75 meter from the floor. This is the diagram of anvil: cutting face, hardy hole, punching hole, tail, body, and beak. This is the anvil. Okay, cutting face like that. Hammer. The classification of hammer is largely according to the size and weight of the hammer used in forging. A smith's hard hammer is a small sized hammer used by the smith himself, and the sledgehammer is comparatively larger in size, behavior, weight, and is used by the smith's helper known as hammerman. The smith's hand hammer is normally a small sized ball peen hammer. Ball peen hammer, another one is the cross peen hammer, another one is the straight peen hammer. Ball peen hammer and face peen hammer. Ball peen, one side there is a pin and wedge and eye, this is the head and face. Another one is the cross peen hammer. Here it is, the diagram is clearly given. Another one is the straight peen hammer. All the hammers are mainly divided into four parts, namely pin, eye, cheeks, and face. The pin is the top part made slightly tapered from the cheeks and rounded at the top. It gets particular form known a ball peen hammer. The face is hardened and polished well and is given slight rounding along the circular edges so that the metal surfaces is not spoiled by the sharp edges when the former is struck by the hammer. The eye is normally made oval or elliptical in shape and accommodate the handle or shaft. For small sized hammer, these handles are made of shishin wood or bamboo, but in case of sledgehammer, the handles made of solid bamboo. Steel wedge is always forced into the handle after it is fitted into the hammer so as to prevent slipping of the hammer of the handle during striking. A Smith hammer is usually ball peen hammer or a straight pin sledge type hammer of relatively small size. Its weight normally varies between 1 kg and 1.8 kg. A ball peen hammer is used for all general work and its pin is employed when light blows at a faster speed are needed, such as in fullering rivet head in a countersunk hole. Sledgehammer are accompanied comparatively 3 to 4 times heavier than the hand hammers. They are available in varying sizes and weight from 3 kg to 8 kg. They are employed when heavy blows are needed in forging and other operations done in heavy jobs. This is the sledgehammer. This is the diagram of sledgehammer. This is the diagram. Another one is the swage block. It is usually a block of cast steel or cast iron carrying a number of slots of different shapes, sizes along its four side faces and throughout the holes from its top face to bottom face. This is used as a support in punching hole and forming different shapes. The job to be given a desired shape and is kept at a similar shaped slot. The hole in the top and bottom faces used in punching, their use prevents the punch from spoiling by striking against a hard surface. After the hole has been punched. This is the swage block. Tongs. They are used to hold the jobs in position and turning during forging operation. They are made of mild steel. Workshop practice, tongs are usually made of two pieces of riveted together to form a hinge. Smaller length of on one side of the hinge carries the holding jaws, which are made in different shapes and sizes to suit the corresponding shape and sizes of the job, and longer portion on the other side of the hinge from the arm, which are held in hand by smith. Overall sizes of the tongs vary according to the size and shape of the job to be held, but commonly used length of the tongs in hand forging vary from 400 mm to 600 mm with the jaws. Opening ranging from 6 mm to 50 mm. Flat or square, another one is the round nose, another one is the hollow nose, and another one is the angle or V nose. Flat square, another one is the round nose, another one is the hollow nose and angle or V nose. This is the flat or square. Okay, flat or square. This is the flat or square. Tongues are usually named after the inside shape of the jaws. Flat tongues are used for gripping thin section and small flat pieces. Round hollow tongues with curved surface inside are used for holding round work. Round hollow tongues with curved surface inside are used for holding round work. Hollow tongues with square jaws are used to hold square or hexagonal work. Pick up the tongues have their jaws so shaped that even small section can be easily picked up. They are not used for holding the work. Another one is the chisel. Chisels are used to cut metals in hot or cold state. Those which are used for cutting the metal in hot state are termed as hot chisel, and others used for cutting in cold state are known as cold chisel. The main difference between the chisel is in included angle at the cutting edge. A cold chisel carries an included angle of 60 degree at the cutting edge, and the latter is well hardened and tempered. It is made of high carbon steel. A hot chisel can be made medium carbon steel. There is no need of hardening. It is used to cut the metal in plastic state. The included angle is 30 degree. Punches are tapered tools made in various shapes and sizes. They are used for producing hole in red hot jobs. A larger tapered punch is called drift. The job is placed on the anvil and the punch is hammered through it up to about half its depth. Is then turned over and punch made to pass through it. Completion of this operation in two stages prevent the job from splitting and full of bursting. Workshop practices actually flatters. These are also known as smoothers. They are made of high carbon steel and consist of square body fitted with handle and a flat square button. They are used for leveling and finishing a flat surface after drawing out or any other forging operation. This is the forging. This is the flatter. Okay, this is the flatter. This is the diagram of the flatter. Now, set hammer. It is made of a tool, steel and hardened. It is not used for striking purpose. Its construction is also similar to that of a flatter but is smaller in size, and it does not carry an enlarged bottom face. It is used for finishing corners formed by two adjacent surfaces at right angles. The job is supported on the anvil and the tool is hammered from the top. This one is the set hammer. Fuller. These tools are made of high carbon steel in different sizes to suit various types of jobs. They are usually used in pairs consisting of top and bottom pillar. Their working edges are normally rounded. They are employed for making necks by reducing the cross section of a job and also in drawing out. Okay, so this is the fuller. Okay, so this is the end of the discussion. Okay. Okay, thank you.
Last, if you like my video, you have to subscribe. Okay, thank you.